In this video, we are going to solve exponential equations that can be reduced to the same base, or they already have the same base. We have done this previously, but the ones in this video are a little bit more complex. So, first example here on the left has 1 over 27 equal to 3 to the 2x power, and we're asked to solve it. So we want to find x. And we're going to use this uniqueness property that we've already seen that says, let b be greater than 0 and b not equal to 1, then b to the x equals b to the y is equivalent to x equals y. This just means that if they have the same base, their exponents must be equal, which makes sense. I couldn't have 3 squared equaling 3 to the 4th power. That doesn't make sense. 9 does not equal 81. That's not true. So if they have the same base, so these are both 3, the exponents must also be equal. We're going to use that to solve for our variables that are in the exponents. In this example, I know that 27 is the same thing as 3 cubed. And then to get it out of the denominator, I have to take the reciprocal, which means that exponent would become negative, because negative exponents take the reciprocal. And now that they have the same base, the exponents must be equal. That means that negative 3 has to equal 2x. If they're not equal, then we'd end up with something like this that can't be true. And now lastly, I need to solve for x. I'm going to divide both sides by 2, and that means that x equals negative 3 halves. This is a type of problem that you can definitely plug that back in and check it to make sure that these two things are equal. In this next example, they already have the same base. This is 4 to the n plus 4 power equals 4 to the 7n plus 7 power. If they have the same base, just set the exponents equal. So n plus 4 has to equal 7n plus 7. Now we have a linear equation that we can solve by getting all of our variables on one side and all of our constants on the other. So I'm going to go ahead and subtract n from both sides. And if I'm moving n to the right, that means I'm going to move my constant to the left. So that's 0. 4 plus a negative 7 is negative 3. 7n minus n is 6n. If I want to get n alone, I have to divide by 6. And then I'm going to simplify that fraction. So negative 3/6 is the same thing as negative 1/2. And again, I could plug this back in to make sure that I am getting a true statement. You go ahead and try the examples on the right-hand side. And these are a little bit different. So 4 and 32 are not the same base. You have to get them to the same base first by factoring and rewriting them. This next example, we have a lot going on here, but the variable is in the exponent. So the goal is to get rid of that variable in the exponent. So that means I have to isolate this term. You have to get rid of this, get rid of the 2, isolate it first, and then see if you can rewrite it with the same base. And the last one, we have seen problems like this with the fractions. Just remember, negative exponents take the reciprocal. Let's see how you did. So as I mentioned, you're going to want to rewrite 4 and 32 because they can have the same base. 4 is the same thing as 2 squared. And that's still to the 3x minus 6 power. 32, if you factored it, is the same thing as 2 to the 5th power. And that's still to the 2x power. Now we have a power to a power. Remember, a power to a power, we're going to multiply those. So this is going to get multiplied. So now it's 2 to the 6x minus 12 power. And on the right hand side, we'd have 2 to the 10x power. So I made sure to distribute this 2 to all of this quantity, 3x plus 6, so 2 times 3x, 2 times 6, and then 5 times 2x gave me 10x. Now they have the same base, and the exponents must be equal. That means 6x minus 12 has to equal 10x. I'm going to get my x's on the same side, because this is a linear equation. That leaves me 10x minus 6x is 4x. And then I divide both sides by 4. And negative 12 divided by positive 4 is a negative 3. Again, feel free to plug that back in and check your work. Next example here, I have to isolate this base with that exponent that has a variable. So first thing I'm going to do, subtract 13 from both sides. Now I have 2 times the quantity 9 to the 2x plus 1 power equals 162. Now you might have the urge to multiply these, but you can't. Exponents is a higher level of operation than multiplication. You cannot multiply these two things together. Okay, don't do that. So to get rid of that 2, I have to divide both sides by 2, because it's 2 times 9 to that power. To undo that, I'm going to divide. Now I have 9 to the 2x plus 1 equals 81. Now these are both powers of 3, so they can be reduced to the same base. 9 is the same thing as 3 squared, and we're taking that to the 2x plus 1 power. And 81, if you factored it, is the same thing as 3 to the 4th power. Now on the left-hand side, I have a power to a power. I'm going to multiply and get 3 to the 4x plus 2, right? 2 times 2x and 2 times 1 will equal 3 to the 4th power. Now they have the same base. I set the exponents equal. I have 4x plus 2 has to equal 4. So this exponent has to equal that exponent. Now I can solve for x. I subtract both sides by 2. I get 4x equals 2, because 4 minus 2 is 2. Divide both sides by 4. And x equals, after you simplify that, down to 1/2. So x equals positive 1/2. In this last example, again, the first thing I'm going to do is take the reciprocal of this 1/5, because I want to have just a base of 5, not a base of 1/5. So to take that reciprocal, that means that 5 has to have a negative 1 power. And on the left-hand side, again, I took the reciprocal, that made the exponent negative, and now it's a power to a power, and I need to multiply, remembering to distribute. So now I have 5 to the negative x, because of negative 1 times x, plus 5, because of negative 1 times negative 5. Now they have the same base. I set the exponents equal. That means negative x plus 5 has to equal 3x plus 4. I'm going to get my x's on the same side. And if I move my x to the right, that means I have to move my constant to the left. 0, 5 minus 4 is 1. 3x plus x is 4x. 4 minus 4 is 0. Lastly, I undo multiplication with division, and that means that x has to equal 1/4. And there you go. So, in general, if they have the same base, set the exponents equal. If there's other things going on, but you have an x in, or a variable in the exponent, isolate that term, get it all alone first, and then in general, try to rewrite them with the same base if you can.